This video is about finding area by integrals continued. Guided practice 5. No calculator based. Find the area of the region enclosed by y equals x squared minus 3x and y equals x minus 3. First of all, when you're looking for the area bounded by two functions, you need to figure out the intersections. Therefore, I will put the x squared minus 3x equals x minus 3 to figure out the intersection. This is a quadratic equation, so move everything to the left side. We want to get the equal 0. We get x squared minus 3x minus x plus 3. So we get x squared minus 4x plus 3 equal to 0. Factor x minus 1, x minus 3 equals to 0. So we get the x1 equals to 1, x2 equals to 3. Then for the y1, we need to plug either this function or this function. Linear function is much easier, so we plug in x minus 3. 1 minus 3, you get negative 2. That's your y1. So we get the negative 2. For the y2, you will get the 3 minus 3 equals to 0. So y2 equals to 0. So we figure out those two coordinates, 1, negative 2, and 3, 0. Then we can sketch the graph. Three, 0 here. 1, negative 2 is here. Then you can connect these 2 points. This will be the y equals x minus 3. For this quadratic function, 1 is greater than 0, so basically it's open up. You can estimate the graph like this. You can label this is y equals x squared minus 3x. Basically, it will pass through this 0, 0. But anyway, just make sure your graph is open up. Whether it's passing through 0, 0, it doesn't matter for this question. Now we can write down the area bounded by these two functions. It's from 1 to 3. And for linear function, x minus 3 minus x squared minus 3x dx. From the graph, you could see y equals x minus 3 is above y equals x squared minus 3x between 1 and 3. Therefore, I use linear function minus a quadratic function. Then we combine like terms for that. You will get the negative x squared minus x squared plus 3x plus 4x minus 3. Then dx. Then you can use this formula. You will get for negative x squared, that is negative x third power over 3 plus 4 times this one, you will get the x squared over 2 minus 3x. Then we can do from 1 to 3. Simplify inside, you will get the 2x squared. Now, we plug in 3 first, negative 3 third power over 3 plus 2 times 3 squared minus 3 times 3. Then minus parentheses here. You will get negative 1 third power over 3 plus 2 times 1 squared minus 3 times 1. This gives you negative 9. This gives you positive 18. Negative 9. So here is a 0. Then go this one. Negative 1 over 3 plus 2 minus 3. That is negative 4 over 3. Then we have this negative sign. You will get 4 over 3. This is the area bounded by these two functions. For guided practice 6, on the same set of axes, graph these two functions, showing axis intercepts and asymptotes. If you set up the window like this, you will get the graph, this one. This will be y equals e to the x power minus 1. This graph will be y equals 2 minus 2 e to the negative x power. For exponential function e to the x power, when x go to negative infinity, let me set up this as y. Y will go to 0. For y equals e to the negative x power, means when x tends to positive infinity, then the y tends to 0. In other words, for y equals e to the x power minus 1, the asymptote line will be y equals negative 1. For this, the asymptote line will be y equals 2. When x approaches a positive infinity, this one is when x approaches a negative infinity, you will get this. So, you will draw, this is the 1, and here's the 1, asymptote line. The axis intercept will be 0, 0. This time you can sketch the graph. Zero, 0. And y equals negative 1. This will be y equals e to the x power minus 1. For another function, the asymptote line is y equals 2. Still pass through this point. This will be y equals 2 minus 2e to the negative x power. Now let's go to b. This is a, go to b. Find algebraically the point of intersection of these two. We will set up e to the x power minus 1 equals 2 minus 2e to the negative x power. First of all, we combine like terms for these two. You can move over here, or you can move negative 1 to the other side. So you will get the minus 3 equals negative 2 times 1 over e to the x power. First of all, we try to get rid of this e to the x power by multiplying by e to the x power for this equation. So we get the e to the x power square minus 3e to the x power, then equals negative 2. You could say this is a power pattern equation. Therefore, get equal to 0. We add to both sides. You get the e to the x power square minus 3e to the x power plus 2 equals to 0. Then we set up e to the x power equals a squared minus 3a plus 2 equals to 0. Then a minus 1, a minus 2 equals to 0. So we get the a1 equals 1, a2 equals 2. Then we plug back in e to the x power equals 1, x equals to 0. E to the x power equals 2. We do natural log both sides. Here you get the x equals natural log of 2. Now we plug in y equals e to the x power minus 1. y1, we label this is x1, here's x2, equals e to the 0 power minus 1 equals to 0. So y1 equals to 0. For y2, e to the natural log of 2 minus 1 equals. This one, they give you 2 because we have a natural log of a of x equals to x. This is the formula. Therefore, you get the 2 minus 1 equals to 1. So y2 equals to 1. So we have coordinates 0, 0, and a natural log of 2, 1. This will be the intersection. Let's go to C. Find the area of a region enclosed by the two curves. We know the intersection will be 0, 0, and a natural log of 2, 1. And this graph is y equals e to the x power minus 1. This graph, that is y equals 2 minus 2 e to the negative x power. So this is a above function, and this is a below function. Therefore, we can set up the area equals from 0 to natural log of 2. 2 minus 2 e to the negative x power minus e to the x power minus 1. We do definite integral of this function. You can put this into a calculator or you can work this out. That is do the distributive property first. You will get 3 minus 2 to the e to the negative x power minus e to the x power. Then that's the definite integral of this function from 0 to natural log of 2. Therefore, for this 3, I will get the 3x. For this, you will get the negative 2 e to the negative x power times 1 over negative 1. That's 1 over 8. Then minus e to the x power from 0 to natural log of 2. Let's simplify this. You will get the 3x plus 2 times 1 over e to the x power, then minus e to the x power from 0 to natural log of 2. Now we will plug in natural log of 2 first. So we have 3 natural log of 2 plus 2 times 1 over e to the natural log of 2 minus e natural log of 2. When you have e natural log of x, that equals to x. So e to the natural log of 2 equals 2. Then minus, we plug in 0, 3 times 0 plus 2 times 1 over e to the 0 power minus e to the 0 power. Therefore, this give you 2. This give you 2. 3 natural log of 2 plus reduce, you will get the 1. Then minus 2. This will be 0. This give you 2 minus 1. So you get the 1 minus 1. Combine like terms, you will get the 3 natural log of 2 minus 2. This will be the area bounded by these two functions. If you use a graphing calculator, put this into the main screen, you will get the answer 0.0794. Now let's go to guided practice 7. The illustrated curves are those of y equals sin x and y equals sin 2x. Identify each curve. For y equals sin x, we know the period equals 2 pi. For y equals sin 2x, the period equals 2 pi over 2, that equals pi. Therefore, for C1 will be sin 2x. C2 will be sin x. For A, C1 equals sin 2x. C2 equals sin x. B, find algebraically the coordinates of A. We will set up sin 2x equals sin x. We have double angle formula. Sin 2x equals 2 sin x cosine x. Therefore, I will get the 2 sin x cosine x minus sin x. I will set up equal 0. Then the common factor will be sin x. And 2 cosine x minus 1 equals to 0. Therefore, you will get the sin x equals to 0 and 2 cosine x minus 1 equals to 0. Then cosine x equals 1 over 2. Therefore, since the domain for x is between 0 to pi, for this x will be pi over 3. This x will be 0. So x1 equals to 0, x2 equals pi over 3. For y1 definitely equal to 0 and y2 equals sine pi over 3. That is a square root of 3 over 2. So we have coordinates 0, 0, and pi over 3, square root of 3 over 2. Now let's go to C. Find the total area enclosed by C1 and C2 for x between 0 and pi. This will be sine 2x. This one will be sine x. Coordinate will be pi over 3. Therefore, the area equals definite integral of sine 2x minus sine x. Then dx plus sine x minus sine 2x. Definite integral of this function from pi over 3 to pi. Then you plug into calculator, you will get 2.5 will be the solution. Let's go to guided practice 8. The shaded area is 0.2 unit square. Find k correct to 4 decimal places. According to the given information, we can write down definite integral of 1 over 1 plus 2x from 1 to k. That equals 0.2. We do know that 1 over x indefinite integral equals natural log of x plus c. Therefore, we can write down natural log 1 plus 2x. Don't forget 1 over a, so 1 over 2. From 1 to k, then equals 0.2. We plug in k first, so natural log 1 plus 2k. That 1/2, let me put over here. Then minus natural log of 1 plus 2 times 0. Then 1 over 2 equals 0.2. This gives you 1. Natural log of 1 equals to 0. So this equals to 0. We can get natural log of 1 plus 2k. That 1/2 equals 0.2. We solve this logarithm function. Multiply by 2 both sides. You will get the natural log of 1 plus 2k equals 0.4. Then using the circle to figure out this argument, base is e. We do know that log base of x equals to y. We can write down b to the y's power equals to x. So we can write down e to the 0.4th power equals 1 plus 2k. Since I'm looking for k minus 1, then divided by 2, k equals e to the 0.4th power minus 1 over 2. We put this into calculator. You will get k equals 0.2459.